It's a time before humans, in the vast expanse of space where stars were still being born. It's here that Earth and Venus were created, sisters separated only by distance. The birth of Venus occurred in the same region of space as our own planet, some 4.6 billion years ago. Just as Earth was forming, so too did Venus, both emerging from a primordial cosmic cloud rich with dust and gas. Astronomers have long noted the striking similarities between Earth and its sister planet, Venus. Both are roughly the same size, about 12,004 kilometers in diameter, and share a rocky composition. Yet despite these similarities, there's a crucial difference that sets Venus apart: its dense atmosphere. This was first confirmed by the Mariner 2 spacecraft in 1962. This discovery revealed that Venus is shrouded in a thick layer of carbon dioxide, making it an inhospitable world despite its close resemblance to Earth. As we delve deeper into the story of Venus, we find that this planet holds a unique place in our solar system. It's not just a sibling to Earth, but a reminder of how small changes can lead to vastly different worlds. This sets the stage for exploring more about what makes Venus both fascinating and challenging, as we uncover why it's uninhabitable, even with its many similarities to our home planet. Now imagine doing the same for over 4,000 years. The height would equal the diameter of Venus. This near-perfect twinning extends beyond just size. Venus is also similar in mass, weighing in at around 4.869 x 224 kgs. To put that into perspective, imagine every person on Earth being a tiny speck of dust, and then multiply the number of people by over 10 million. That's how much Venus weighs compared to Earth. It's as if our planets are distant siblings, separated at birth. Both worlds share a similar proximity to the Sun, with Venus being the second planet from our star. This proximity means that Venus completes a full orbit around the Sun in about 224 Earth days. That's not only quicker than our year, but also makes a day on Venus longer than a year on Earth. Yet, despite these close similarities, Venus remains uninhabitable due to its extreme conditions. Its thick atmosphere and intense heat make it a stark reminder that the universe can create astonishing twins with vastly different destinies. In the blazing inferno of Venus, the heat is not merely intense, it's almost unimaginable. The surface temperature can reach up to a scorching 864 degrees Fahrenheit, 462 degrees Celsius. This isn't just hot, it's hot enough to melt lead. Imagine a world where the heat is so extreme that it could liquefy common metals. This isn't some distant science fiction. This is the reality of Venus. The heat of Venus poses one of the biggest challenges to any notion of life or human habitation on this otherwise Earth-like planet. The dense atmosphere of Venus acts like a giant greenhouse, trapping the sun's heat and making the surface temperature unbearably high. To put this into perspective, consider that the average temperature on Earth is a comfortable 59 degrees Fahrenheit, 15 degrees Celsius. The difference in temperature between our two planets is staggering. The extreme conditions of Venus serve as a stark reminder that while some planets might appear similar to ours, the reality on their surface can be incredibly different. Despite its harsh environment, Venus continues to captivate scientists and stargazers alike as we strive to understand the mysteries of our cosmic neighbor. One of the key aspects contributing to Venus's extreme conditions is its unique atmosphere. Unlike Earth, Venus has an atmosphere composed mostly of carbon dioxide. This dense layer of gas makes up approximately 96% of the planet's atmosphere. This intense pressure is equivalent to being 1 kilometer underwater in Earth's oceans. Imagine the weight and heat this atmosphere must exert on any potential inhabitants. But it's not just the density that makes Venus's atmosphere so inhospitable. The clouds of sulfuric acid that blanket the planet add another layer to this toxic blend. These clouds, which rain corrosive droplets onto the surface, reflect sunlight back into space, creating a powerful greenhouse effect. Despite its harsh conditions, Venus continues to fascinate us, pushing scientists to explore further and uncover the mysteries of our cosmic neighbor. Venus, the planet most similar to Earth in size and composition, has another fascinating feature: volcanoes on its surface. Despite its scorching temperatures and dense atmosphere, Venus is not devoid of geological activity. These volcanic features contribute significantly to the planet's unique landscape. Imagine a mountain range extending for 930 kilometers across the surface of Venus. This is Maxwell Montes, the longest volcanic feature in the solar system. Standing at about 11 kilometers high, it dwarfs Earth's tallest peak, Mount Everest. However, these volcanic features are not the only evidence of Venus's fiery past. The planet boasts over 1,000 impact craters larger than 5 kilometers, 3.1 miles. These massive scars serve as reminders of intense geological events that have shaped the planet. These impact craters, some as deep as the tallest mountains on Earth, highlight the sheer force and violence involved in these geological events. The combination of intense heat and massive pressure has crafted a landscape that is both awe-inspiring and inhospitable. While the volcanic activity on Venus adds to its intrigue, it also underscores why this planet remains uninhabitable. The extreme conditions make any form of life as we know it nearly impossible. Perhaps the day will come when we can harness the secrets of Venus's volcanic landscape to better understand our own planet and its dynamic nature. Venus is one of these planets, making it unique among its fellow telluric planets. This retrograde rotation of Venus leads to some fascinating and unusual conditions on the planet. For starters, a sidereal day on Venus, the time it takes for the planet to complete one full rotation on its axis, is approximately 243 Earth days. This is significantly longer than a year on Venus, which lasts about 225 Earth days. As a result of this slow rotation, the sun rises in the west and sets in the east on Venus. This creates a bizarre cycle where daylight on one side of Venus can last for almost 180 Earth days, nearly half the length of its year. This extreme heat is a stark contrast to the night side of Venus, where temperatures can drop significantly. The retrograde rotation adds another layer of complexity to the already harsh conditions on Venus. Despite being the planet most like our own, these unique features make it an environment that is far from habitable for humans. But how do we know so much about Venus, the most Earth-like planet in our solar system? The exploration of Venus has been a thrilling adventure filled with challenges and triumphs. The Soviet Union's Venera spacecraft led the way, launching multiple missions between 1961 and 1983 to unravel Venus's mysteries. In the late 70s, NASA joined the effort with its Pioneer Venus mission, launched in December 1978. This ambitious project aimed to study Venus's atmosphere and shed light on why it is so different from Earth's. NASA's Magellan mission in 1990 revolutionized our understanding of Venus by providing detailed radar maps of its surface. Even NASA's Parker Solar Probe made a detour to Venus in 2018 and 2019, using its gravity to correct its trajectory en route to the Sun. But the rewards are immense. Each mission has peeled back another layer of Venus's complexity, revealing a world that is both fascinating and uninhabitable. As we continue to explore this enigmatic planet, we may one day unlock the secrets of its past and uncover clues about the future of our own world. Venus has no moons or natural satellites. While Earth has a single, stable moon that stabilizes our planet's tilt and helps regulate climate, Venus lacks this stabilizing influence. Without the gravitational pull of a satellite, Venus experiences intense wobbles in its axis known as true polar wandering. This makes predicting weather patterns and climate cycles nearly impossible. Imagine trying to build a simple house in such conditions. The walls and roof would need to withstand an immense, constant force that our current construction methods simply can't handle. In summary, Venus is uninhabitable due to its intense atmospheric pressure, toxic atmosphere, extreme heat, and lack of stabilizing moons. These factors combined make it impossible for humans to survive or even thrive on this planet. As we continue to explore the fascinating story of Venus, one name stands out in the quest to unlock its mysteries: NASA. Born on October 1, 1958, NASA has been at the forefront of space exploration for over 6 decades. Now, with Roman preparing to launch, we look forward to new revelations about dark matter and dark energy. But what excites many scientists is the potential to discover thousands of worlds beyond our solar system. Future missions to Venus hold great promise for expanding our understanding of this enigmatic planet. While similarities exist, such as its size and composition, the challenges it presents make human habitation impractical. The intense atmospheric pressure, toxic atmosphere, extreme heat, and lack of stabilizing moons create conditions that are inhospitable to humans. Yet, these very obstacles drive our curiosity forward. Looking ahead, we can anticipate groundbreaking discoveries and insights into the complexities of Venus. With each mission, we move closer to unraveling the mysteries of this intriguing planet. In the grand tapestry of our solar system, Venus remains a captivating puzzle. As we delve deeper into its secrets, we look forward to future advances that will illuminate this fascinating world further. One of the enduring mysteries of Venus is the phenomenon of vacuum decay. This theoretical process involves a sudden, catastrophic phase transition in the universe's vacuum energy state. Some scholars believe it could potentially lead to the destruction of all matter as we know it, but we don't really know if vacuum decay is real. In fact, scientists are still working on understanding the fundamental nature of our universe and whether such a dramatic event could occur. The mysteries deepen when we consider the extraordinary shape of certain features on Venus, like the volcanic feature called Maxwell-Montes. The mysteries of Venus are far from solved, and that is part of what makes this planet so fascinating. Its proximity to Earth and its similarities in size and mass only add to the allure. As we delve deeper into its secrets, we look forward to a future where many of these enigmas will be unraveled. Venus is a fascinating world, so close to Earth in many ways, yet so utterly different when it comes to habitability. One key factor that makes Venus inhospitable is its surface pressure. This extreme pressure has significant implications for potential human habitation. Under such conditions, any structures or equipment would need to withstand an immense weight, far beyond anything we're accustomed to on Earth. Moreover, the human body itself is not designed to endure such pressure. Our bones and muscles are adapted to the relatively low atmospheric conditions of Earth's surface. Exposure to Venus's surface pressure would be catastrophic for us. Gravity is another factor that sets Venus apart from Earth, despite their similar sizes. Venus has a gravity that is about 86% of Earth's. While this might not sound like a significant difference, it means that objects on Venus would feel lighter than they do here. For example, a person weighing 75 kilograms on Earth would only weigh about 64 kilograms on Venus. This might seem like an advantage, but it also presents challenges for maintaining stability and performing tasks that require precise control of one's body weight. Combining these factors of extreme surface pressure and significant gravitational differences makes Venus an incredibly challenging environment for human habitation, despite its initial allure as Earth's twin planet. As we continue to explore and understand more about Venus, these factors serve as crucial reminders of the delicate balance that makes our own planet so uniquely suited for life as we know it. The next time you look up at Venus in the night sky, remember this: while it shares many similarities with Earth, its intense surface pressure and strong gravitational pull make it a place where human habitation would be fraught with unimaginable challenges. This is not just about the physical conditions. it's also about the profound sense of awe and wonder at the complexity of our cosmic neighborhood. From the moment of its formation, Venus began a journey marked by geological wonders and cataclysms that have shaped it into what we see today. Its story is one of both similarities to Earth and stark differences that make it uninhabitable. But unlike Earth, Venus has a geological timeline that is far more turbulent and extreme. These craters serve as testaments to a past filled with cosmic collisions that sculpted the surface of Venus. While Earth also has its share of impact craters, the density and size of those on Venus paint a picture of a planet that has experienced far more intense geological events. The geological history of Venus is a tale of both parallels and stark contrasts with Earth. By understanding the profound differences in their geological timelines, we gain insights into why Venus evolved so differently from its early similarities to Earth. While Earth's magnetic field is an essential part of its protective bubble, Venus lacks such a global magnetic field. This absence has profound consequences on the planet's habitability. Imagine trying to protect your home without a secure door or alarm system. That's what Venus faces with its lack of magnetic field. Earth's magnetic field creates a magnetosphere, which acts as an invisible shield against the solar wind, charged particles that stream from the sun. This protective layer deflects harmful radiation and traps the solar wind, preventing it from stripping away our atmosphere. Venus, however, does not have this luxury. Without a strong magnetic field, its atmosphere is exposed and vulnerable to the relentless solar wind. Over time, the constant barrage of charged particles has eroded Venus's atmosphere, contributing to its inhospitable environment. This dense atmosphere might seem like a protective layer, but it's no match for the persistent solar wind without a magnetic field to back it up. Think of it as trying to hold a piece of paper against a strong gust of wind. No matter how tightly you grip it, the wind will eventually tear it away. Without the Earth-like protections of a magnetosphere, Venus's atmosphere has been steadily degraded over billions of years. This constant stripping away of the atmosphere is one of the key factors that make Venus uninhabitable today, despite its initial conditions favoring habitability. As we delve deeper into Venus's history and current state, we see that while it started out with many promising similarities to Earth, the lack of a global magnetic field is one crucial difference that has significantly shaped its evolution. This peculiar rotational pattern is believed to have influenced Venus's climate and environment in profound ways, contributing to its current state of extreme heat and dense atmosphere. These missions revealed fascinating insights into Venus's history, including evidence that liquid water once flowed on its surface billions of years ago. Scientific models suggest that Venus may have had an ocean covering as much as 80% of its surface. This discovery is significant because it indicates that Venus, despite its current inhospitable conditions, once had the potential to support life as we know it. What happened? Why did Venus lose its water and become the scorching world we see today? Scientists believe that a combination of factors, including the intense solar wind and lack of a global magnetic field, played a crucial role in stripping away Venus's atmosphere over time. The absence of a strong magnetic field meant that Venus could not protect its atmosphere from being gradually eroded by solar radiation, leading to the loss of water and other gases over billions of years. Investigating this past water on Venus not only deepens our understanding of its early conditions, but also highlights the delicate balance of factors needed for a planet to remain habitable over time. As we continue to explore our cosmic neighbor, these findings add another layer to the story of Venus as a planet that could have been like Earth, furthering our exploration into what might have gone wrong and why it evolved so differently. This journey through Venus's past water and habitability potential underscores the importance of studying our solar system's history to better appreciate the complex dance of planetary evolution. Perhaps as we uncover more secrets about Venus, we will gain a deeper appreciation for Earth's unique suitability for life and the delicate balance that makes our planet home. For now, Venus serves as a reminder of how different paths can lead to vastly different outcomes, even when starting from similar beginnings. Beneath the dense atmosphere of Venus lies a world of extremes. At its core, Venus harbors a molten metal ball, unlike Earth's iron-nickel mix. The mantle surrounding the core is composed mainly of silicate rocks. Unlike Earth's, Venus's crust isn't divided into tectonic plates. This unique structure contributes to Venus's lack of plate tectonics. Without the motion and interactions of plates, Venus is geologically inactive. The absence of plate tectonics also means that heat cannot escape efficiently from its interior. This results in a surface temperature reaching up to 864 spheres 460-degree spheres, making it uninhabitable for most life forms. Additionally, without the magnetic field generated by Earth's core, Venus lacks protection against solar winds. Despite its similarities to Earth, Venus's internal structure and lack of a global magnetic field make it fundamentally different from our home planet. While Earth formed farther from the Sun's scorching influence, Venus's closer position subjected it to different conditions early on. Some theories propose that impact events in the solar nebula might have nudged proto-Venus even closer to the Sun, further intensifying its exposure. These formative differences set Venus on a divergent path from Earth. While both planets share many similarities in size and composition, the stark contrast in their atmospheres hints at distinct evolutionary histories. Imagine two siblings raised under vastly different circumstances, one nurtured by gentle sunlight, the other bathed in unforgiving solar heat. This metaphor underscores the profound impact of initial conditions on Venus's development. This dense, hostile environment stands in stark contrast to Earth's hospitable climate, shaped by our protective magnetic field and the life-giving water that covers most of our planet. The tale of Venus is a poignant reminder that while two worlds can start from similar places, their evolutionary trajectories can be dramatically altered by seemingly minor initial differences. Imagine, if you will, what it would be like to stand on the surface of Venus. The sky above isn't a gentle blue, but rather an eerie yellow-orange hue. The atmosphere of Venus is a thick blanket of carbon dioxide, making it the densest and hottest among all the planets in our solar system. Those clouds you see aren't made of water vapor like on Earth. Instead, they are composed of sulfuric acid. The winds on Venus blow at tremendous speeds, reaching up to 400 kilometers per hour in the upper atmosphere. These super-rotating winds whip around Venus so fast that the entire planet completes a full rotation in less than 24 hours. In fact, Venus is the only planet in our solar system that rotates in the opposite direction of its orbit. This retrograde rotation creates unique weather patterns that make the Venusian climate one of a kind. Lightning storms are another fascinating feature of Venus's atmosphere. These storms are so intense that they generate a type of lightning we don't see on Earth. Unlike Earth, Venus lacks plate tectonics, the dynamic process where sections of the Earth's crust move and collide, recycling material into the mantle. This absence has significant implications for understanding Venus's geological history. The lack of plate tectonics on Venus means that the planet's crust is thicker and more static, leading to a different pattern of volcanic activity and surface features compared to Earth. Despite sharing similarities in size and composition, Venus's surface features reflect the volatile history and stark contrast with Earth's dynamic landscape. The immense impact craters, vast lava plains, and unique tesserae formations offer a glimpse into the planet's past that is both captivating and enigmatic. But what makes Venus truly unique is its climate. While both planets experience a greenhouse effect, the heat-trapping mechanisms on Venus are so intense that they make the planet uninhabitable for humans. All these factors combined make Venus a planet that's inhospitable to human life, despite its many similarities with Earth. It serves as a stark reminder of how delicate the balance is. Even a slight shift can lead to drastic changes. And as we continue our exploration, this understanding of Venus's climate helps us appreciate the delicate balance that makes Earth a habitable home, even if it means we might never set foot on our sister planet. Venus, our sister planet, is the closest Earth-sized world in the solar system. Yet its surface is profoundly different from ours due to one dominant force, volcanism on Venus. But the volcanism on Venus does not just manifest in grand mountain ranges, it has also created unique features called coronae and arachnoids. These are circular or spider-shaped structures that form around large impact craters, indicating the intense volcanic activity underneath. So, as we continue our exploration of this fascinating sister planet, it is clear that volcanism has been a dominant force shaping Venus into the planet we see today, a world both strikingly similar to Earth, yet profoundly different. Understanding this geological activity allows us to appreciate how natural forces can drastically alter planetary surfaces and atmospheres, even on a world that is, in many ways, similar to our own. Despite the challenges posed by its environment, Venus continues to captivate our imagination, offering insights into the dynamic processes that shape our universe and the delicate balance that makes Earth a habitable home. Venus's atmosphere is a complex structure, divided into several distinct layers that contribute to its inhospitable conditions. These atmospheric layers play a crucial role in shaping the planet's environment and make Venus unique among its celestial neighbors. At the very top of Venus's atmosphere lies the ionosphere, a layer where sunlight breaks apart molecules into charged particles called ions. This thin layer acts as a protective shield against solar radiation. Below the ionosphere is the thermosphere, a layer characterized by extreme temperatures that can reach up to 250 degrees Celsius. Here, the atmosphere is so thin that a molecule might travel hundreds of kilometers before colliding with another. Deeper still lies the mesosphere, where temperatures drop dramatically to around 90 degrees Celsius. This layer is known for hosting phenomena like noctilucent clouds, which can be observed as glowing lights in the night sky. Below the mesosphere is the stratosphere, where temperatures begin to rise again, reaching a stable level around 350 degrees Celsius. This layer is dominated by the presence of sulfur compounds that shape the upper atmosphere of Venus. The troposphere, the lowest layer of Venus's atmosphere, is where most weather phenomena occur. This dense layer traps heat extremely efficiently due to the high concentration of carbon dioxide. These sulfur compounds play a significant role in shaping Venus's upper atmosphere. They absorb sunlight and heat up the air around them, creating a complex dynamic that further contributes to the planet's extreme temperatures. The interaction between these layers is complex. Heat trapped in the lower layers rises, while cooler air from above sinks, creating a continuous cycle of convection that adds to Venus's extreme conditions. These missions have allowed scientists to map out the intricate dynamics and interactions within Venus's atmosphere, revealing the delicate balance that makes Earth habitable but renders Venus inhospitable. While the atmospheric layers of Venus make it an uninhabitable world, they offer a unique window into the processes that shape our solar system and the conditions necessary for life as we know it. Understanding these layers deepens our appreciation for Earth's habitable environment, reminding us of the delicate balance that sustains life on our pale blue dot. As we continue to explore Venus and its atmospheric layers, we gain valuable knowledge about the cosmos and the precarious balance that supports life on our own planet. This deeper understanding not only enriches our view of Venus, but also underscores the importance of preserving Earth's unique conditions that make it a habitable home. Venus, our closest planetary neighbor, harbors a striking phenomenon: sulfuric acid clouds that shroud its atmosphere. These unique formations are not mere meteorological curiosities. They play a critical role in the planet's extreme climate. To understand how these clouds form, we must delve into the chemical reactions taking place in Venus's atmosphere. Carbon dioxide, the primary constituent of Venus's atmosphere, combines with sulfur and oxygen to create sulfuric acid. These acidic particles then condense to form the thick, opaque clouds that give Venus its distinctive appearance. The winds on Venus are slow but powerful, capable of moving these dense clouds at high altitudes. These winds circulate the sulfuric acid clouds, ensuring they remain a constant feature of the planet's atmosphere. The sulfuric acid clouds not only give Venus its unusual visual profile, but also play a significant role in maintaining the planet's extreme temperatures. They reflect sunlight back into space, contributing to Venus's scorching surface temperatures that reach up to 864 degrees Celsius. This intricate interplay between the planet's atmosphere and its unique weather patterns highlights another critical factor that sets Venus apart from Earth. While Venus and Earth share many similarities, it is these subtle yet profound differences that define their unique identities. A key aspect that distinguishes Earth from Venus is the loss of water from Venus's atmosphere over time. This significant event has had profound implications for the planet's habitability. Scientists believe that early in its history, Venus might have had oceans similar to those on Earth. Over billions of years, however, the intense solar radiation and lack of a global magnetic field led to the evaporation of these waters into space. The loss of water also prevented Venus from developing a robust carbon cycle. On Earth, the exchange of carbon dioxide between the atmosphere and oceans helps regulate climate. Without this balance, Venus's carbon dioxide levels have skyrocketed, further exacerbating its greenhouse effect. The delicate balance of Earth-like conditions on Venus was disrupted by these atmospheric changes, highlighting the importance of water for planetary habitability. Even small changes in a planet's atmosphere can lead to catastrophic effects over time. As we explore the fascinating story of Venus, from its formation and similarities to Earth to the challenges that make it uninhabitable despite being the planet most like our own, we see the crucial role water plays in shaping the world's climate and suitability for life. Understanding these atmospheric changes helps us appreciate the delicate equilibrium needed to sustain life on Earth and the profound consequences that can arise from even subtle planetary shifts. While Venus's atmosphere is a stark reminder of the conditions necessary for habitability, it also underscores the remarkable resilience and adaptability of life on Earth, which continues to thrive within our planet's unique atmospheric balance. The atmosphere of young Venus was likely much thinner than it is today. With less carbon dioxide and other greenhouse gases, temperatures would have been cooler. This early habitable period for Venus lasted until the planet's runaway greenhouse effect kicked in. As more and more carbon dioxide was released into the atmosphere, temperatures began to soar. The thickening atmosphere trapped heat, creating a hothouse environment that quickly evaporated any remaining water. This phase marked the end of Venus's habitable period. Understanding this early habitable period is crucial to piecing together what went wrong on Venus and why it diverged so dramatically from Earth's path. By learning about the conditions necessary for habitability and how they changed over time, we can gain insights into what makes our own planet so special and resilient. These volcanoes spew vast amounts of carbon dioxide into Venus's atmosphere, further thickening its layers and trapping more heat. This runaway greenhouse effect is a key factor in making Venus uninhabitable. Imagine standing on Venus. The heat would be so intense that lead would melt. This is a stark reminder of the importance of understanding these processes and their potential implications for our own planet. By studying Venus's intensified greenhouse effect, we can gain insights into how runaway climate changes might unfold elsewhere in the universe. This knowledge is crucial for our quest to understand habitability and resilience of planets like Earth. Understanding these mechanisms also underscores how delicate and unique the conditions on Earth are. Our planet's balance is a testament to its resilience in the face of environmental changes. Did you know that Earth's magnetic field is like an invisible shield, protecting us from the solar wind? It's a crucial component of our planet's habitability, making life as we know it possible. But let's travel back in time to explore another world, Venus, and unravel the role its early magnetic field played in shaping its fate. But the loss of its magnetic field might have set in motion a chain reaction leading to Venus's current, inhospitable conditions. Without this protective shield, the solar wind could have gradually eroded away any remnant of that habitable atmosphere. It's a stark reminder of how delicate and interconnected the elements that sustain life truly are. A magnetic field might seem like a small detail in the grand scheme of planets, but it holds immense power over their fate. Exploring the fascinating story of Venus highlights the crucial role magnetic fields play in protecting a planet from solar wind and maintaining a habitable atmosphere. Without this invisible shield, even a planet as promising as Venus can become uninhabitable over time. Like a newborn child, Venus was once similar to its sibling, Earth. Both were rocky worlds with a thick atmosphere. But while our home planet has remained largely unchanged over the eons, Venus has undergone dramatic transformations. One of these changes is perhaps the most intriguing: the potential existence of early oceans on Venus. Evidence from ancient rocks suggests that Venus may have once hosted vast bodies of water, a surprising twist for a planet now known for its scorching deserts. Scientists speculate that in the distant past, Venus's climate was far more hospitable. Climate models indicate that early Venus could have been cool enough to support liquid water on its surface. A day on Venus was much shorter then, only around 243 Earth days, rather than the current 243 Earth years. Imagine a world where days were as long as our years, a slow, languid rhythm that might have allowed life to take root. But something changed. The once promising conditions degraded into the hellish landscape we see today. The planet that could have been our twin in habitability now stands as a stark warning of how quickly and drastically climates can shift. With each new discovery, the story of Venus unfolds like a cosmic mystery novel full of twists and turns. And with each page turned, we gain a deeper understanding of our own planet's fragility. This incredibly long day is a stark contrast to Earth's 24-hour rotation and highlights the unique challenges that make Venus an uninhabitable world. One of the key processes contributing to this state is atmospheric escape, the gradual loss of gases from a planet's atmosphere into space. The thick atmosphere of Venus is primarily composed of carbon dioxide, a gas that traps heat very efficiently through a process called the greenhouse effect. One of these mechanisms is hydrodynamic escape, where the solar wind can strip away lighter atoms from the planet's atmosphere. Over billions of years, this process has likely contributed to Venus losing a significant amount of water. Another key process is photodissociation, where sunlight breaks down water molecules into hydrogen and oxygen atoms. The hydrogen atoms can then escape into space more easily due to their lower molecular weight. This stark contrast between Venus and Earth underscores the delicate balance of conditions necessary for life as we know it. While both planets share many similarities, the atmospheric escape processes that have shaped Venus make it a world vastly different from our own. Imagine if you could travel back in time to when Venus was still a water-rich world. The sight would be remarkable, a planet teeming with potential life that has since been transformed into the scorching, barren landscape we see today. As we continue to study our sister planet, these processes provide valuable insights into the complexities of planetary evolution and the importance of maintaining a balanced atmosphere for sustaining life. Understanding why Venus's atmosphere has become so inhospitable compared to Earth's is a crucial step in appreciating the unique conditions that have shaped our own planet's habitability. And as we delve deeper into the mysteries of our cosmic neighborhood, it becomes clear that each planet has its own fascinating story to tell. Diving into Venus's geological history reveals a planet shaped by ancient volcanic activity. Its surface is marked with vast lava plains, testifying to the tumultuous events that have molded its landscape over time. One of the most significant volcanic features on Venus is Maxwell Montes, which stands as the highest peak on the planet. This colossal feature hints at the intense geological activity that once shaped Venus's surface. Scientists believe that the slow retrograde rotation of Venus on its axis contributed to this volcanic past. Furthermore, the dense atmosphere of Venus, primarily composed of carbon dioxide, acted as a thick blanket, trapping heat and sustaining these volcanic events over eons. This ancient volcanism not only shaped Venus's physical landscape, but also significantly impacted its atmospheric composition. The release of sulfur dioxide and other volcanic gases into the atmosphere contributed to the creation of dense clouds of sulfuric acid that enshroud Venus today. These clouds reflect sunlight and create the brilliant shine for which Venus is known. Its appearance as the morning star and evening star are a result of these volcanic processes. While Earth's tectonic activity is driven by plate movements, Venus lacks this dynamic process, leading to a static surface dominated by ancient volcanism. Venus's unique climate and surface dynamics have sparked intriguing questions about its potential for harboring life. Enter astrobiology, the scientific field dedicated to exploring the possibility of life beyond Earth. Biosignatures are one of the key tools astrobiologists use in their search for extraterrestrial life. These are gases or molecules that could indicate the presence of living organisms. In 2020, a groundbreaking discovery by an international team of scientists revealed the detection of phosphine in Venus's atmosphere. Phosphine is highly unusual because it quickly breaks down in an oxygen-rich environment like Earth's atmosphere. This makes its presence on Venus all the more intriguing. However, phosphine could also be produced by non-biological processes, such as volcanic activity or chemical reactions within Venus's sulfuric acid clouds. This complexity in interpreting the data underscores the challenge of identifying definitive biosignatures. Despite these challenges, the discovery of phosphine has reignited scientific interest in exploring Venus for signs of life. NASA's Pioneer Venus mission and the Mariner 2 probe have provided invaluable insights into Venus's atmosphere, setting the stage for future research. The search for life on Venus is part of a broader quest to understand our place in the universe and the potential existence of other living worlds. As our technology advances, so too does our ability to decipher the mysteries of the cosmos. The tantalizing possibility of life on another planet continues to captivate scientists and dreamers alike. While no definitive evidence has yet been found, the pursuit of understanding life's potential beyond Earth remains an exciting and enriching journey. Its orbit, however, reveals crucial differences that have shaped Venus's climate over time. In contrast, Earth's sidereal day is roughly 23 hours and 56 minutes long. This unusual rotational period means that a single Venusian day is longer than the time it takes for Venus to orbit the Sun. Imagine if Earth took nearly 243 days to complete just one full rotation on its axis. Our calendar year would only cover about 3 Venusian days. At its closest point to the Sun, Venus is about 0.72 AU, astronomical units away, while at its farthest, it's around 0.73 AU. This orbit variation might seem small, but it significantly influences Venus's climate over time. Over millions of years, the shifting distance to the Sun caused variations in solar radiation received by Venus. These changes could have contributed to the runaway greenhouse effect that makes Venus's surface so inhospitable today. While understanding all factors at play is complex, studying Venus's orbital characteristics provides valuable insights into the conditions necessary for a planet to support life as we know it. As our exploration of the cosmos continues, These lessons from Venus underscore the critical role that orbital mechanics play in shaping a planet's environment and habitability. Venus, our neighboring planet, shares more than just its proximity to Earth. It is often referred to as Earth's sister planet due to their similar size and composition. But before Venus became the inhospitable world it is today, scientists believe that it may have experienced dramatic climate cycles. These conditions could have made Venus habitable for some time, with temperatures and pressures that might have supported life as we know it. However, something dramatic changed on Venus, leading to its current state of extreme heat and high atmospheric pressure. Scientists believe that Venus might have undergone a runaway greenhouse effect, where the planet's temperature rose so high that water vaporized and was lost to space. This process could have been exacerbated by the lack of a magnetic field to deflect solar winds. The result was a world that became too hot for water to remain in liquid form, making it impossible for life as we know it to survive. Understanding these early climate cycles on Venus can provide valuable insights into the dynamics of planetary atmospheres and the conditions necessary for habitability. For now, we know that Venus's early climate cycles were dynamic and potentially habitable. These discoveries not only deepen our understanding of Venus, but also remind us of the intricate balance needed for life to thrive on a planet. As you gaze at Maxwell Montes, imagine the colossal forces that once reshaped this alien landscape. These volcanic hotspots were likely active during Venus's early formation, contributing to its unique geology and extreme climate. The slow retrograde rotation of Venus is a stark reminder of the powerful tectonic activity that once dominated its surface. While these forces have subsided, their legacy lives on in the planet's unforgiving climate and distinctive geological features. This ancient tectonic activity not only shaped Venus's surface, but also played a crucial role in determining its potential habitability. Despite being the planet most like Earth, Venus's extreme conditions make it uninhabitable for humans. As you reflect on these discoveries, consider the delicate balance needed for life to thrive on any planet. Long before the intense heat and thick atmosphere that we now associate with Venus, this planet may have been much more hospitable. The evidence of stable and potentially habitable climate conditions on early Venus comes from geological clues on its surface. This thicker atmosphere might have allowed Venus to retain heat from the sun, creating a stable and potentially habitable environment. Imagine the sight of rivers flowing across Venus's surface and oceans covering large portions of its land. However, the stability of this early climate was short-lived. A runaway greenhouse effect likely led to the rapid loss of water and the creation of the scorching atmosphere we see today. This transformation must have been swift and dramatic, ending any potential for habitability on Venus. But the delicate balance needed for life to thrive was lost, leaving Venus as a desolate and inhospitable world. Scientists believe that Venus's initial atmosphere was likely similar to Earth's, rich in carbon dioxide and nitrogen. But over time, volcanic activity on the planet's surface significantly altered this composition. The dense clouds of sulfuric acid that shroud Venus today are a stark contrast to its past. The planet has been undergoing significant atmospheric loss, with lighter gases like hydrogen and oxygen escaping into space. This process, driven by the intense solar wind, has led to a dramatic shift in Venus's atmospheric composition. The once breathable atmosphere is now toxic and oppressive. Despite its similarities to Earth, the factors that led to Venus becoming uninhabitable are stark. Volcanic activity and atmospheric loss have conspired to create a planet most like our own, yet fundamentally different. The story of Venus's atmosphere evolution serves as a critical reminder of how delicate the balance is for life to thrive. A seemingly small shift in conditions can lead to drastic consequences. Though Venus once held promise, it now stands as a cautionary tale of how the forces at play in our cosmic neighborhood can dramatically alter a planet's fate. Understanding Venus helps us appreciate the intricate dance of celestial bodies and their atmospheres, deepening our understanding of both our similarities and differences with this sister planet. Let's journey back to the early days of Venus, when its fiery core was still young and restless. As the planet spun on its axis, a dance of heat and pressure began deep within its mantle. This is where the story of early tectonic activity and volcanism truly unfolds. Imagine plate tectonics in action, similar to what we see on Earth today. Giant slabs of rock were constantly moving and colliding, driven by the planet's internal heat. This activity was far more intense than anything we witness now. Think about the sheer scale of these events. Each eruption was like 1,000 earthquakes happening at once. The atmosphere, already dense with carbon dioxide, became thicker and more toxic. Over time, this relentless volcanism shaped Venus's surface in profound ways. Massive lava plains stretching hundreds of kilometers were formed, creating a landscape unlike any other in our solar system. Scientists believe that some of the largest volcanoes on Venus, like Maxwell Montes, were forged during this intense period of tectonic activity. But why did Venus become so different from Earth? One theory suggests that the lack of plate recycling led to a buildup of heat and pressure that caused these extraordinary eruptions. This early volcanism also played a crucial role in shaping Venus's atmosphere. The constant release of greenhouse gases from the volcanoes trapped heat on the planet, creating the scorching temperatures we see today. As we look back at Venus's past, we see how geological processes, seemingly so violent and destructive, can actually shape a planet. And while Venus may not be habitable anymore, its story teaches us so much about the intricate dance of celestial bodies and their atmospheres. But it wasn't always this way. In fact, Venus might have once looked remarkably like our own planet, complete with vast oceans and complex hydrological systems. The evidence for ancient water on Venus is compelling. In 2017, scientists announced that they had found unmistakable signs of past rivers and lakes on the planet's surface. These features suggest that Venus once had a robust hydrological cycle, with rivers flowing into lakes and eventually into larger bodies of water. The existence of these ancient waterways is significant because it indicates that Venus once had a climate capable of supporting liquid water on its surface. Moreover, the presence of water would have played a crucial role in shaping Venus's early atmosphere and climate. Water vapor can act as a powerful greenhouse gas, trapping heat and warming the planet's surface. This ancient water cycle might have made Venus more habitable than it is today. However, something went terribly wrong over time, leading to the loss of this vital resource. Today, Venus is a barren world with surface temperatures hot enough to melt lead and an atmosphere composed mostly of carbon dioxide. The idea that it once teemed with water seems almost impossible. But the geological record tells a different story, one that reveals a planet with a complex hydrological history and a climate that could have supported life as we know it. They remind us that, even on planets far from our own, the dance of water and climate can create conditions that might be conducive to life. And perhaps, one day, we will find more evidence that confirms Venus once harbored oceans teeming with life. For now, the story of ancient water on Venus serves as a poignant reminder of the planet's lost potential and the importance of understanding the intricate cycles that govern our universe. In the vast expanse of our solar system, there exists a planet that was once considered a potential home for life, Venus. Long before it became the scorching world we know today, early Venus bore striking similarities to Earth, including the presence of vast oceans. Evidence gathered by orbital probes and geochemical models suggests that ancient Venus was blanketed in vast bodies of water. These early oceans on Venus could have provided the initial conditions necessary for life to take hold. Though the exact extent and duration of these oceans remain topics of ongoing research, their existence is supported by mineralogical findings from probes like NASA's Pioneer Venus. Geochemical models further suggest that the surface pressure on Venus was once much lower than it is today, making conditions more hospitable to water. At a time when Venus was potentially habitable, the surface pressure might have been as low as 1/10 of what it is now, a stark contrast to the crushing atmospheric conditions we see today. This stark difference underscores just how much Venus has changed over billions of years. Understanding the early ocean conditions on Venus not only expands our knowledge of the planet's past, but also sheds light on why it is no longer considered a potential home. By exploring these fascinating early oceans of Venus, we gain a deeper appreciation for the delicate balance of conditions that make life possible. And perhaps, just perhaps, these insights will guide us in our search for other habitable worlds beyond our own. The story of Venus, Earth's sister planet, is one of both similarity and stark difference. Once thought to be a lush world teeming with life, it now stands as a barren, scorching globe devoid of any atmosphere we could breathe. The key to understanding this transformation lies in the concept of atmospheric escape. Atmospheric escape is a process by which planets lose their atmosphere over time, significantly altering their climate and habitability. In the case of Venus, several mechanisms have contributed to this drastic change. Venus does not possess a global magnetic field like Earth's, making it particularly vulnerable to this type of atmospheric erosion. Another significant factor is hydrodynamic escape due to extreme heat. Venus is the hottest planet in our solar system, with surface temperatures reaching up to 864 degrees Fahrenheit. This intense heat causes lighter elements like hydrogen and oxygen to gain enough energy to escape the planet's gravity. Furthermore, photochemical reactions in the upper atmosphere play a crucial role. Ultraviolet radiation from the sun breaks down molecules such as carbon dioxide and water vapor, leading to the loss of lighter atoms like hydrogen and oxygen. These processes combined have resulted in Venus losing its once lush atmosphere, leaving behind a dense cloud of carbon dioxide and sulfuric acid that traps heat and creates the scorching conditions we see today. It's fascinating to consider that, despite its initial similarities to Earth, Venus has evolved into a world where human life could not survive. This transformation underscores the critical role atmospheric conditions play in planetary habitability. As we continue our search for habitable worlds beyond Earth, understanding how atmospheres evolve over time will be crucial in identifying which planets might still harbor life or could potentially support it in the future. Perhaps, just perhaps, by learning from Venus's past and present, we can better navigate our own planetary future. One crucial factor setting Venus apart is its low albedo, the measure of how much light an object reflects. Earth's average albedo is about 0.3, meaning it reflects roughly 30% of the sunlight that hits it. Venus, on the other hand, has a significantly lower albedo, often measured at around 0.1 or less. This means it reflects only about 10% of incoming solar radiation back into space. This low reflectivity might seem like a trivial detail, but it plays a pivotal role in Venus's runaway greenhouse effect. The sunlight that isn't reflected contributes to the heating of its dense atmosphere, trapping heat and creating surface temperatures hot enough to melt lead. To put this into perspective, imagine a giant mirror the size of Earth. If our planet had an albedo as low as Venus's, it would be reflecting sunlight with the efficiency of a single-pane window in winter, barely any light bouncing back. The consequences are stark. While Earth's average surface temperature hovers around 15 degrees Celsius, Venus experiences temperatures up to 864 degrees Celsius, 460 degrees Celsius. The dense atmosphere and low albedo work in tandem to create an uninhabitable world. Understanding these differences is key. They highlight how subtle variations in reflectivity can drastically alter a planet's climate, even when starting conditions are nearly identical. So the next time you gaze up at Venus shining brightly in the night sky, remember that this sister's planet reflects light differently than Earth, shaping it into a world of extremes, all while sharing our ancient cosmic origins. The bright light of Venus, our sister planet, is a beacon in the night sky. But this luminescence isn't just a matter of reflection, it's shaped by intense solar radiation. This dense atmosphere traps solar heat more effectively than Earth's, creating a runaway greenhouse effect. Unlike Earth, which rotates once every 24 hours, Venus takes a staggering 243 days to complete just one rotation. This slow spin subjects Venus to prolonged exposure to solar radiation, amplifying its atmospheric heat. Imagine trying to breathe under such immense pressure while enduring the scorching heat of a runaway greenhouse effect. NASA's Pioneer Venus mission in 1978 revealed the intricate dynamics of this hostile environment. It found that Venus's atmosphere swirls like a pot of boiling water, with winds exceeding Earth's hurricane speeds. These powerful winds further circulate the trapped heat, ensuring that every part of Venus experiences extreme temperatures. In contrast, Earth's atmosphere has a protective layer of ozone that shields us from the full brunt of solar radiation. Without this protection, Earth too would succumb to the relentless solar heat and become as inhospitable as Venus. Understanding how solar radiation shapes Venus's atmosphere offers insights into the delicate balance of Earth's climate. This similar birthplace and age suggests that early Venus could have been very different from what we see today, perhaps even habitable. One possibility is that liquid water once existed on its surface. While Venus is incredibly hot now, its slow retrograde rotation means it takes 243 Earth days to complete one day. In the distant past, before its atmosphere thickened and superheated, this longer day might have allowed Venus to maintain a more Earth-like climate. Additionally, Venus once had a magnetic field similar to Earth's. Magnetic fields are crucial for habitability. They deflect harmful solar winds and help sustain atmospheres. The presence of such a field indicates that Venus might have experienced a similar dynamo effect as Earth, where the planet's rotation and iron core generate magnetic shielding. More intriguingly, some scientists speculate that an ancient biosphere might have existed on Venus. The thick atmosphere of carbon dioxide could theoretically support primitive life forms similar to those found in extreme environments on Earth. These conditions, while speculative, show that habitable zones can be incredibly delicate and subject to change over time. Despite its current state, Venus once held the potential for life. This highlights just how fragile the balance of habitability can be. It's a reminder that while we often think of planets as static, they are dynamic systems evolving over billions of years. Understanding these past conditions not only helps us appreciate the diversity of our solar system, but also sheds light on the precarious nature of life's sustainability. For now, Venus remains a tantalizing enigma, a planet that could have been habitable and perhaps once was. In 2007, a study published in the Astronomical Journal suggested that dust clouds surrounding Venus could contain tiny satellites or moonlets. These tiny fragments, no bigger than pebbles, orbit Venus within a dense layer of dust. The origin of these hypothetical moonlets is intriguing. Some theories propose that they might be remnants of a once larger moon, possibly torn apart by Venus's intense gravity or collisions with other celestial objects. Understanding the presence and nature of these moonlets could offer valuable insights into Venus's early history, including its formation process and the conditions that prevailed during its youth. Scientists are not just interested in Venus for its own sake, but also because it offers a window into Earth's past and future. By studying the evolution of Venus and its potential moonlets, we might gain deeper understanding of how our own planet has changed over time. But for now, these moonlets remain elusive, hidden within the dense dust clouds that surround Venus. Their discovery could be a major breakthrough in our understanding of not just Venus, but also the early conditions of our own solar system. By studying these small fragments, we take another step forward in uncovering the full story of Venus, from its birth to its present state, as a scorching, inhospitable world that once might have been more like home. As our technological capabilities and scientific methods advance, we edge closer to solving the riddles of Venus, including whether it once harbored life or might yet again in the distant future. In the early days of Venus, before it became the scorching world we know today, scientists believed the planet's climate was quite different. Geological evidence suggests that Venus once had a thicker atmosphere composed of carbon dioxide and nitrogen. This denser air trapped more heat, creating a greenhouse effect that was less intense than the one we see today. Scientists speculate that this milder greenhouse effect might have allowed liquid water to exist on Venus's surface for extended periods. Over time, as Venus's rotation slowed and its atmosphere grew thicker with volcanic activity, the planet began to heat up more rapidly. This shift into a runaway greenhouse effect eventually made Venus inhospitable to any form of life that could have potentially existed there. Studying these early climate cycles helps us understand the dynamic nature of Venus's history and why it became uninhabitable. For a time, Venus might have looked much like our home planet, with a magnetic field that could potentially provide some protection from the solar wind. But this early protective shield was not meant to last. Venus's magnetic field was weaker and shorter-lived compared to Earth's. The solar wind, a constant stream of charged particles from the sun, is powerful enough to strip away atmospheres over time. A strong magnetic field acts as a shield, deflecting these particles around the planet. Without this defense, Venus's atmosphere was left vulnerable. Over time, this exposure to the solar wind may have contributed to the thinning and ultimate loss of Venus's once thick atmosphere. The delicate balance needed for a planet to maintain habitability over time was disrupted on Venus. Its early magnetic field was not strong enough or long-lasting enough to safeguard its atmosphere against the relentless solar wind. This balance is crucial for planets like ours, where a magnetic field has played a vital role in preserving our atmosphere and enabling life as we know it. As we continue to study Venus, the story of its early magnetic field serves as a reminder of the intricate dynamics that shape planetary evolution and the delicate conditions necessary for a world to remain habitable.